Hello, everyone, and welcome to our webinar with topic the cloud in examples and how to benefit from modern technologies in the cloud. First, a few things about myself and our company, Profinet. And Profinet is here already for 23 years. The majority of our customers are from Czech Republic, but we have also, customers in other European countries. We are number 2 in custom development in Czech Republic, and we have over than 550 consultants. Now, a few words about myself. My name is Petr Filas. I'm a senior data consultant and head of project Profinet Azure competency. I work for Profinet for over than 13 years on various projects with a focus on data integration, data management, and data warehousing. My roles usually on this project were data architect, solution architect, or management consultant. And I worked for customers like O2, Prague Airport, and Česká spořitelna, which is the biggest Czech bank. Let's mention more words about our competencies in Profinet, because Profinet is not just about a cloud, we do much more. There is enterprise integration, business intelligence, big data and data science, of course, software development and application outsourcing. Okay, so what is going to be about today? We will first do the very brief cloud introduction, and after that, we will see a practical demonstration of 2 different cloud use cases. And because it's practical, we will focus on solutions in Microsoft Azure. We will show 2 scenarios. So in the first scenario, we will build a public API application for connecting the legacy systems to a public API provider. And we will try to deliver a modern user experience through this. Second scenario will be about building a machine learning application to leverage cognitive services for business process digitization. Okay, so first, the cloud introduction. My opinion is that cloud is literally everywhere around us today. And I think there are just 2 perspectives how to perceive the cloud. So there is a personal perspective, when we consume or produce the content, so we consume the resources, or there is a professional perspective, when we create solution based on cloud services. So let's say we mediate resource consumption. Yeah, there is one more obligatory slide with reasons why to use the cloud. So in the first place, there is accessibility. So as I mentioned, the cloud is everywhere around us and it's accessible. There is elasticity. So the cloud is usually very cost efficient. If you need more power, you can scale up, or if you need less, you can scale out. It's ready out of the box, so you can use it immediately, and it has usually a better security. Yeah, then there is my favorite reason. It's just a cool thing to use. Okay, so cloud services. I think it's impossible to know all the cloud services in just for a single provider, because nowadays Azure has more than 200 services, and these services are changing rapidly. So every month, new services are created and the existing are changed. So the question is, how to choose the right service? And I think the answer is either you know it, so you have the experience, or you have to learn how to use it. And that's what we will focus on this webinar today. So we picked 3 services in Azure. The first service is the app service. It's very popular and well-known, I think well-known service for application runtime in cloud. The other services are computer vision and machine learning. They are maybe not so well-known services to provide image processing. So in case of computer vision, it's out of the box with low code. It serves for simple scenarios, and machine learning, on the other hand, is fully equipped ecosystems for more complex scenarios. So it's time to bring you a bit in the action. So it's poll time. Let me just enable the poll. And I would kindly ask you to fill the questionnaire. I think it should appear right now in front of you. So I will read these questions. So please mark the cloud providers you have experience with. So we have the big three: AWS, Azure, Google Cloud Platform, or the other. Okay, now I see it's changing. Thank you. Second question is, how many services do you know or use in your favorite cloud platform? So there are numbers, or yeah, there is option for awesome people if they know all of them. And the last question is, please mark the Azure services you have experience with. So far I can see that most of you has experience with the app service. That's great. And with computer vision. Okay, so there are still some votes. So I will give you 1 minute or a few more seconds more. Okay. So now I can end the poll and show you the results. So we can see that in the first question, okay, there are people that know Azure, that's great, and the other cloud platforms. Most of you know till 10 services in your favorite cloud platform. So that's great to hear. And yeah, as I mentioned, a lot of you know the app service. Okay, so let's proceed to our scenarios. To make our journey more interesting, I made out a story for these two scenarios. So let's imagine you are responsible for running an airport and you want to use the cloud to improve your business. What is actually the biggest problem of airports? And I think you already know, it's delays. And by delays, I mean delays of flights. So, of course, there are delays that are out of our control, like technical difficulties or even accidents. Therefore, we will focus just on delays we can reduce, and we just pick 2 of them for our scenarios. So for the first scenario, we want to improve passengers' information awareness to reduce delays caused by late boarded passengers. So we will provide them an easy access to flight informations. In the second scenario, we want to evaluate the flight handling process in a real time for early detection of possible delays. And for this, we will do the object and task detection from the CCTV stream. So scenario 1, building a public API integration application. I repeat our goal. So we want to improve passengers' information awareness to reduce the delays caused by passengers. The approach will be following. We will let passengers use their favorite messaging app to receive flight updates. And for that, we will create a connection between our legacy systems and social media app. And for this purpose, for this case, we choose the Facebook Messenger. And it's easy to use. Just scan the QR code and subscribe it, but by entering the flight number, we will show in a second. A few words about architecture. On the left side, we can see our legacy system that contains the flight data and that is pushing the data updates to our, let's say, bridge application in Azure. On the right side, there is a Facebook API that passes subscription requests from clients and to our app on one hand, and on the other hand, it sends back the flight data updates for those subscriptions. And that's how it actually looks like from the client's perspective. So we can see the Facebook Messenger user interface with flight notifications. And you can see that in case of Facebook Messenger, you can add some graphics and styles to looking more cool. Okay, let's see the demo. For this demo, I will use the Postman app. If you don't know it, Postman app is just an application that serves for sending an HTTP request, and we will send it to our application in Azure. So in this scenario, Postman will basically serve as a mock of our legacy system that is pushing the flight updates out. Okay, so I already set it up, everything in Postman, so we can see the creation message for the flight. It's Lufthansa flight LH1393 flying to Frankfurt. And that's our application address, URL. So we created a flight successfully. So the application right now knows about the flight. So we can grab the phone, scan the QR code, click on the URL, it opens the Facebook Messenger, and we can type in the flight number. So we put an EK13139, which is actually the wrong flight. I didn't create, sorry. And if we try it again with the LH1393, we will get a confirmation of the subscription, and we will receive other flight updates. So if we proceed to check-in counters allocation, so we just create it, send it, and it will appear on our phone immediately. If we open those check-ins, so we will send an error message with update. So check-ins are opened, we can see it. And yeah, there's, I think, one more. Yeah, go to gate status. So we send this message, it will appear again on our phone screen. What's the conclusion and benefits of this scenario? It's a simple subscribe and publish scenario that enables you to connect your legacy system to modern communication channels. So you can use widespread messaging platforms instead of traditional ways like emails or SMS. The application is applicable for other messaging platforms like WhatsApp, Hangouts, and so on. And from technical perspective, it's nice that you don't need a DMZ because your Bridge app runs safely in your cloud. Okay, that was the first scenario, and we can continue to the second one, which is the building and machine learning application. I repeat again the goal. So the goal is to evaluate the flight handling process in real time for early detection of possible delays. We will choose the following approach. We will detect and check events on RAM during the aircraft handling process. For this, we will use the CCTV stream. Interesting thing is that these surveillance cameras are usually not used continuously, but just in case if there are some problem. And this means that the continuous service quality of handling procedures usually isn't evaluated in real time. So that's something we want to prove. So we will leverage the potential of machine learning in Azure. Here we can see on a picture possible causes of delays. So if there are not resources on the place in the right time, yeah, like cargo boxes, bridge, tank track, and so on. But how does it work overall, image processing? So basically our task is to recognize objects from a picture, from a CCTV stream, because CCTV stream is just a series of pictures. So the recognition algorithm must be pre-trained on labeled input. So we are talking about supervised learning. Then the algorithm is used to detect and label objects in new unlabeled input. If I repeat it again, or in the first step, we will get the labeled training data, go through the learning process, and get a model. When we are satisfied, we can use this model on real life data to get labeled real life data. Okay, and how does it work with out-of-the-box models in Azure? You can prove it by yourself. Simply create a computer vision resource in Azure and start object detection using API calls. This resource using a general model that is trained to recognize common objects. So we can expect that there will be a low ratio of successful recognition in case we want to detect specific objects. And we can show it in our next demo. So what I have done here is I simply created a resource, computer vision. And if we take a look on settings of this resource, we see that we basically need two things. The first thing is the API key for authentication, and the second one is the API address. So we'll go to the documentation, and our task here is to detect objects. So we will choose this option. And yeah, okay, our resources are located in West Europe. So choose the location. And we can see, I think below, yeah, we can see the API address we need to use. And there's also mention that we can in the body of the request, we can set either the raw image binary or the image URL. So if we switch to the Postman, again, this is everything set up already. I set up the API key, set a binary image, the API address. So everything is ready. And I think in a second we will see the picture, the original picture we sent for processing. Okay, here it is. So there are few airplanes sitting or airport at the airport. So that's the image we will pass. There are also some vehicles and tracks. So we will see the result in a few minutes. So if I send this image, we get a result that contains detected objects, and there is a position of the objects with and height of the object, and yeah, there is of course label of this object that it's airplane, and then there is a confidence interval. And this result we get for all detected objects from the picture in one single response. So if we take this response, this result, and combine it with the original image, we can get following results. So you can see that almost every airplane was detected, one is missing. And you can notice that no vehicle actually was detected. Okay, so that's our first try, first result. If we try it with a different picture from a different camera angle or different camera view, we can see that right here, some vehicles and tracks were detected. On the other hand, the airplane itself was detected just partially, just the wing of the airplane. So how does it work when things get more serious? In more complex scenarios, API calls are not so effective, usually because of the overhead of communication. The call of the API could take hundreds of milliseconds. So in that case, we need to process the stream or pictures directly using image processing engine, usually in Python. And for this purpose, we create a resource called machine learning that provides the machine learning studio, which contains cool features like pre-processing, Python scripting, model tuning. So in the Azure Machine Learning Studio, we took the raw input video stream and used the pre-trained model, which is usually done by a bunch of Python scripts, and these scripts run on the compute cluster, and then we get the results. And if we again combine it with the original stream, we get the augmented output stream. And we can see it on our last demo. So we can see that there are already some detected objects, like cargo box, tank track, luggage and loading track, and the jet bridge. And here comes the airplane. So to achieve our goal, I think already right now we can see that, for example, all resources or required resources are at a place and ready. So there are no possible delays happen so far. Okay. What's the conclusion of this scenario? Of course, there is a follow-up. We can take the extracted data and build logic on it for our early warnings. Next is that with easy task, you can benefit from easy setup and get fast results fast, but these results might not be so accurate. And with more challenging tasks, some coding is still needed. So you have to pre-process the data or the stream, combine it, fine-tune your model, and so on. What's the overall conclusion? In a cloud, you can benefit from many low or no code services that are really fast ready. The tricky part is how to choose the right one. So either you know, or you have to learn. And the cloud provide a fast track option for delivering a solution. So for easy scenarios, the path is very quick and effective, but in more complex scenarios or solutions, you still need a bit of engineering. And with this approach, a new challenge arises because the less you have to focus on deployment and implementation tasks, the more you have to pay attention to security and architecture. And that's actually topics that we didn't touch today. They are good. That's good topics for maybe for the next webinar. Okay, that's it. And I think we can proceed to your questions. So please, if you have a question, and I hope you will have, type it in a chat and I will try to answer. So I will give you I'll just open the chat, give you a minute to send a question. Oh, that would be a pity if there is no question. Okay, so Jakub asks, what is the biggest benefit of cloud services if you had to choose just one? So I think the biggest benefit is that you can start very fast prototyping or validating your idea from technical perspective, and it gives you a bit of feeling of independence or freedom. So you can achieve this result very fast. You don't need your infrastructure. So that's my opinion. What is the biggest benefit? Okay, so I will wait just a while. Okay, if there are no other questions, I would thank you. I would like to thank you for your attention. And yeah, I would kindly ask you if you have a few minutes to fill in our survey. I would really appreciate it. So thank you very much and have a nice rest of your day. Bye. Oh, sorry. I get it. Sorry. So we are not ending. Jerry is writing another question. How powerful are the cloud services if you compare them like AWS versus Google versus Azure? Yeah, that's a great question. Unfortunately, I'm specializing on Azure, so I cannot compare. I know some services from other cloud platforms, but this is something everyone has to test and check before the project and make the decision which cloud wants to use. So maybe if you can add well, from which perspective you want to compare them, because you can compare the price, you can compare the number of services, or wait, so I'll wait. Okay, that's a good question, but I think you can find it on internet if you want to compare services. But what can be done is that if you have a vision, what do you want to achieve in the cloud, then of course you can compare the solution in both clouds, in AWS or even in all of three. So after you specify your requirements, you can compare it. Okay. So I think, oh, thank you. Okay, I think that's pretty much it. So again, please fill the survey. I would appreciate it. And thank you very much for your attention. Have a nice day. Bye.